X for negative X, I know very well. The odd exponent 5, 3, and 1 change, and the other no. Entonces, analyze one more time the chain of sign. I can see negative positive, one chain of sign. Positive positive, no. Positive positive, no. Positive positive, no. Positive positive, no. Only one, entonces capital M es 1. Therefore, fortunately, we have only one possibility, que es 1. So 1 minus 1 is 0. You subtract the even number. 0 is 1. Minus 2 is negative 1. Negative 1 has no sense. It's stupid. Entonces, conclusion, our example contains 4, 2, or none, positive, real 0, and 1, real negative. Okay, entonces I am doing the table immediately. That summarize everything, positive, negative, complex, and total. Total. I know que the degree is 5, entonces this row is always 5. And we have 3 possibilities, no? 4, 2, 0, I copied that like that. 4, 2, 0. And negative only 1, 1, 1, 1, only one value. Complex is 0 complex because 4 plus 1 plus 0 is 5. In that case, 5 also. Entonces, 2 plus 1 is 3 plus 2 is 5. No? And remember, the complex is always even. So it's impossible to have 3 complex numbers. No. O es 0, o es 2, or 4. In this case, 5 again, that's 4. So we have 3 possibilities. Possibility 1, possibility 2, and possibility 3. I guarantee you that when I finish this problem, we determine what possibility is true and the other is not true. Okay, does everyone follow me or no? No? Complicated? Easy. Let's go to the rational 0. Okay, the formula is plus or minus. Go ahead.
Can you explain how you got
what part? The table?
the table.
The table, okay. Don't worry. The table contains always one column.
Okay.
This column is positive, negative, complex, and total.
Okay.
I know que total is always 5 because the degree of our polynomial is 5, correct?
Yes, which is the first number.
No, exactly. Degree, remember definition is higher exponent. Okay. So one theorem que we studied last class say that the degree of the polynomial represents the amount of 0 of our polynomial. Okay. The degree of 5 is always 5.
That's I don't know
exactly, but I don't know exactly the distribution. What is positive, what is negative, and what is complex. The positive is determined by this expression. This expression gives me 4, 2, and 0. I copy 4, 2, and 0. The negative is determined for this expression. Only 1. 1, 1, 1. But the complex is subtraction because I know in total we have 5. Therefore, 4 plus 1 is 5 plus 0 is the amount of total 0 that we have in the polynomial, no? Si es 2, 2 plus 1 is 3 plus 2 is 5. So you determine this subtraction. You add in this and this together, 2 plus 1 is 3, and 5 minus 3 is 2. Likewise, 0 plus 1 is 1, and 5 minus 1 is 4. This is the complement. Okay? Do you see it? Good, very good.
Yeah, I see it.
Super.
All right, thank
you. This is Descartes. Descartes idea. Descartes rule. Give me one intuition about the 0 of the polynomial. Another is rational. Rational is plus or minus P over Q. In our example, this is P. P is 32. And Q is 1. Remember, P is the coefficient without X. This is P. And Q is the coefficient, 1 in this case, of the higher degree. Entonces es plus or minus 32 divided by 1, ¿no? Entonces es nice because 1 is, es like invisible divider. Entonces plus or minus 32. And the list of the potential rational zero are any multiple of 32. Entonces plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, and plus or minus 32. Inside this set, we can find the zero. Entonces, this is a long process. You try one by one, using long division, and determine what actually is the zero of this example. Do you understand the idea for the rational? This is rational. This is the idea. This idea is called rational potential zeros of the polynomial. Always is the formula is plus or minus p divided by q. This is the formula. This is our important formula. Okay, let's go. Let's move on to the complicated part. The complicated part is scientific division. Remember, recommendation. This is the format for the scientific division. And you copy here the auxiliary thing is x to the fifth power, x to the fourth power. This is auxiliary. I like that. X to the cubic power, x to the second power, x to the one power, x to the zero power. You copy only the coefficient again. Our example 1, 1, minus 6, 12, minus 40, and 32. Okay. Entonces you select inside this list here what is the divisor you want to apply. This is too long process. And remember my recommendation in this moment you plot in decimals. Decimals help you after I want to see decimals in this example to pick this guy. Well, let me try negative 4. Okay, negative 4 is inside this. Look at that. Negative 4. Negative 4. I select negative 4. Why? Because I saw in decimals. Right? Let's do it scientific division. Bring down 1, multiplication, negative 4. Negative 3, because negative 4 and positive 1 and negative 3 together, no? This is 12, that negative 3 times negative 4 is positive 12. This is 6, a multiplication 6 times negative 4 is negative 24. We combine later on here is negative 12, and negative 12 times negative 4 is positive 48. We combine later one more time at 4. If 4 no is 8, because 48 minus 40 is 8, of course. A multiplication negative 8 and positive 8, sorry, and negative 4 is negative 32. I discovered that the remainder is 0. Therefore, I prove using scientific division the factor x plus 4, remember opposite sign, x plus 4 belongs to the polynomial. The remainder is 0. So you try and remainder is not 0, it's because this factor don't belong to the polynomial. And you try another, discard. Suppose when I perform the scientific division, I don't get 0. So you eliminate this. No, but in this case, no, because I get 0. 0 remains, that means it belongs to the polynomial. Okay? Everyone follow me? It's clear? It's confusing? Let me try positive 1. Bring down 1. 1 times 1 is 1. This is a minus 2, no? This is multiplication is negative 2. This is 4. Multiplication here is 4. And negative 8. Multiplication, this and this is negative 8. Oh, again, remains 0. Therefore, the factor x minus 1 belongs to the polynomial. Remember, the scientific division I am doing using positive 1. However, in the factorization, I put minus, opposite sign. One more. I pick 2. Bring down 1. Multiplication is 2. Is 0. 0 times 2 is 0. And 4. 4 times 2 is 8. Subtraction 0 again. And we have x minus 2 is also a factor of the our polynomial. Yeah, I stop. Why I know I stop? I stop because here the remaining part is x to the 0, x to the 1, x to the second, es quadratic. And quadratic is super easy by factorization, no necessary scientific division, or using quadratic formula. Entonces, basically, I can see this part is missing. This factor is x squared plus 4. Okay? This factor is x squared. This x squared is this, and this 4 is this. And x to the 1 power is missing because the coefficient is 6. I know that this is irreducible quadratic. Because actually, we have 1 negative, we have 2 positive, and I suppose we have here 2 complex. In total, 2 plus 2 is 4 plus 1 is 5. It's exactly the degree. Let me see in the Descartes rule. In the Descartes rule, we have, look here. This column. This column, we investigate, okay, we have 2 positive, 1 negative, 2 complex. Exactly, we found here. And the factorization for the our polynomial is, I copy the factor 1 by 1. It doesn't matter the order because it's multiplication. Okay. And this is a factor 4, but of course in real field, because we're using only real number. And now I know that part is irreducible quadratic expression. Therefore, the factorization is complex or imaginary. And the factorization in the complex field is something like that. The real part stays the same. When you break it down, this in xx, where come from this x is square root x squared, and square root 4 is 2, pero 2i. 2i. Plus and minus. This is the factor 4 also, but in the complex field. Real field, fancy R. Complex field, fancy C. Complex. Any question? It's easy, it's complicated, too long? In the test, no. In the test, I ask you specifically. I want to, for example, one question is doing the only the Descartes rule, analyze that part. Another question is doing the rational expression. Another is check it out the factor, see this factor belong or no, using scientific division, but not the whole problem. Because we have 16 questions or 12, I don't remember. Entonces es no too long, it's specifically that. The next thing I want to show you, I need to show you, so you have no question, no problema, guys, no problema. You understand very well or no? Confusing, very confusing. Good.
Just with the I, that's what confuses me.
Okay. Don't worry, I explain now. Do you see the board now? Okay. I have no idea about this guy, but this guy is x squared plus 4. I force it to be 0. I try to solve this equation. I move forward to the right hand side to the minus 4, apply square root both sides, x alone, because x squared and square root cancel out each other, and it's a plus or minus 2i, because the square root 4 is 2, no? And negative inside the radical is imaginary number. That is the reason that the 2 0 of this part is positive I and negative I. And together, let me show you, miss. Well, another way to visualize this idea. Suppose I have no idea, and you apply FOIL, multiplication, x squared, multiplication, this and this, is minus 2xi. Multiplication, this and this is plus 2xi. Doesn't matter the order. And this together is minus 4i squared, because 2 times 2 is 4, no? Y I times I is I squared. That part is cancelled. It's the same and opposite sign, it's 0. However, x squared, and this is I negative 4i squared, but I know that I squared is negative 1. You replace negative 1 here, and negative together plus. And we come back to the same expression. Okay. Any question? Any question? No, no, no. Yes, yes, yes. Okay, let's go to see the job completely doing and Desmos. No, to Desmos is like a, a verification. No, okay, the thing we are doing is okay, but you say no, professor, I am solving using Desmos. No, and the algebra I don't know anything. No, hello, what the hell, right? Okay, this is Desmos representation for this example. Look at that. Okay, you see Desmos? I copy here my polynomial. Look at that. This is my polynomial. Example 5. Yeah, I discover. Well, look at that. This is the, like I make a zoom. This is the 0. The 0 is negative 4, 0, 1, 0, 2, 0. This is the x-intercept. And 0, 32 is the y-intercept. I suppose here. 0, 30. That's it. It's very, very, not weird, but it's complicated to see everything. You make a zoom, 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 so you lost information. Okay, I suppose in one moment we have a peak of the hill here, pero es 200 something, right? But don't worry, you click in the house and you create the full zoom. Is the elegance. Any question? Any question? No, no, no. Okay. No, no, no. Okay, so we come back to the, well. Let me see. This is the whiteboard. Do you see the whiteboard now or no? No?
No.
No? Okay.
No.
No. Okay. Whiteboard. Now, you see? Whiteboard.
Yes, sir.
Okay. Let me try to what do you think? You feel strong on this or you need one more example?
One more example, please.
Okay, one more example, please. Okay, go ahead. Let's do number 6. Number 6 is f of x is equal, again, is x to the 5th power plus 4 x to the 4th power minus 13 x to the 3rd power minus 44 x to the 2nd power minus 68 x minus 240. This is our polynomial function. Degree equal 5. Therefore, we expect 5, 0. Include, when I say 5, 0, include a real, positive, negative, repetition, multiplicity 2, because maybe there are sometimes, not always, but sometimes 0 gets repeated. So, for example, negative 1, 2 times, entonces es multiplicity 2. And also the complex. And the complex, remember, is coming by a pair of conjugate. Always conjugate. Conjugate is, remember, complex number 2 plus 3i. The conjugate is 2 minus 3i. The imaginary part, you change the sign. This is conjugate idea. And the 0 of the polynomial coming by pairs of conjugates. Okay? Okay, let's do it by the scatter rule first. The scatter rule is, it's a positive, positive. Doesn't change the sign. It's a positive, negative. Change. It's a negative, negative. Stay, stay, stay. Wow. P is 1. We have only one change of sign in our original polynomial. Therefore, the amount of positive real zero is 1. Remember, this number you're subtracting even numbers, subtracting 0, subtracting 0 is 1. Subtracting 2 is negative 1. Doesn't have no sense when it's negative because we are talking about the amount of 0. Negative 2, what the hell is that? Nothing. And you are doing reflection now. And the reflection, we change the sign only of the term that contains all the exponent. It's minus x to the 5th power plus 4x to the 4th power plus 13 x to the cubic power minus 44 x to the 2nd power plus 68x minus. Everyone follow me? You understand very well this idea or no? Or it's confusing? Confusing or clear? Okay, one more time, I analyze the chain of sign. This is negative and this is positive. One chain of sign. Stay. One chain of sign. One chain of sign. One chain of sign. In total, we have, let me see, 1, 2, 3, and 4. 4 chain of sign. Therefore, the amount of negative 0 is 4, is 2 or 0. You subtracting that number, 4 minus 0 is 4. 4 minus 2 is 2. 4 minus 4 is 0. 4 minus 6 is negative 2. Doesn't work. Because so you take only the answer que is natural number, no? No, no negative. So this helped me to create the table. The table, remember, contain positive, contain negative, contain complex, and total. So we have possibility 1, possibility 2. It's a coincidence that in this example we have 3 possibilities. And it's 3 because we have 1, 2, and 3 numbers here, right? Entonces, en positive, it's obvious that we have only one possibility. Guess what? 1, 1, 1. It's this guy. But in this case, no. We have 4, 2, 0. Yeah, I know in total we have 5, 5, 5. Because the degree is 5, no? Degree 5. Now we have 0 complex, we have 2 complex, we have 4 complex. So finally, when you determine this guy, what column is the corresponding? Okay, it's true. This part, plus or minus P divided by Q, it's a little bit crazy because P is 240 and Q is 1. Actually, it's plus or minus 240 over 1. Okay, it's plus or minus 240. No? So we have a lot of possibilities. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus, This is too long. Entonces, the last one I know get 240. Don't worry for this. When it's a big number, entonces it's more, you lost information, no? It's not clear. You're confusing. However, I go to decimals. In decimal, I realize what is the good candidate to be good in the scientific division. No? Scientific division. Remember the format. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1, x to the 0. So I try using negative 5 because I saw in this negative 5 is 0. But I prove algebraically now. Yeah, I copy the factor. The factor is 1, 4, negative 13, negative 44, negative 68, and negative 240. This is the coefficient of the original polynomial, no? Let me check again just in case. Original is 1, 4, negative 13, negative 44, negative 68, and negative 40. Okay. Bring down one and multiplication. 1 times negative 5 is negative 5. Therefore, here is negative 1 when you combine that term. Negative 1 and negative 5 together is positive 5, this is negative 8. And negative 8 times negative 5 is 40, positive 40, and combine that is negative 4. Multiplication negative 4 and negative 5 is 20. And 20 combine that term here is negative 48, no? And for negative 48 multiplication by negative 5, I put in my calculator or by hand 48 times 5 is 40, carry that 4, and this is 20, and 4 is 24 to 40. Pero es positive to 40, no? Because negative times negative positive, now zero remainder. Good. And the factor x plus 5 belong to the polynomial. Remember, opposite signs. Si es negative here, I put positive. It's supposed that you understand why, no? Or no? Okay. Let's continue the long process of the synthetic division. I try using negative 3. Bring down 1, negative 3, negative 4. This is 12, but 12 positive because negative 4 and negative 3 is 12. And this is positive 4, and this is negative 12. And those are negative 16, no? This and this together. And 16 times 3 is 48, but 48 positive because negative times negative positive, 0 remainder again. Therefore, the factor x plus 3 belongs. This is this to the polynomial. Now 4. 4. Bring down 1. Multiplication 4. 0. Multiplication is 0. 4. 4 times 4, 16 positive, 0 remainder. This idea, this guarantee, this is the most important. I'm happy when you get 0 remainder here because I proved somehow that the factor x minus 4 belongs to the polynomial. Now we have 1, 2, 3. This represents quadratic polynomial. Degree 0, degree 1, degree 2 is a square. And this is the factor again, similar to another example. Not always happen, but in this case was a coincidence. X squared plus 4. Therefore, the factorization of the polynomial is f of x is equal x plus 5, it was the first factor, x plus 3, second, x minus 4, and x squared plus 4 in the real field. In the complex field, well, we did before, the real factor stay the same. This is 4, but this is imaginary. In this case, it's x, 2i, 2i. And this is the factorization in the complex field. Wow, too long, I know. Any question? Just in case, to make sure everything is okay, yeah, I get 100 points in the test. I go to Desmos to see the answer. The answer, remember, is negative 5, negative 3, and positive 4. It's a 0, the real 0. Okay, in the graph, you see only the real. The imaginary is invisible because the imaginary living in another dimension, not in the real dimension. Let me try to see Desmos now. There you go, Desmos. Okay, here, Desmos. Do you see or no? Do you see Desmos? Yes or no? Hey.
Yes, I see it.
Okay, help me. This example 5, now we are doing number 6 example. Number 6, remember, is this polynomial. X to the fifth power plus 4, x to the fourth power minus 13, x to the third power minus 44, x to the second power minus 68, x minus 240. I realize that we have 3 0, negative 5, negative 3, positive 4. It's the only 2 negative and 1 positive. This is a real 0. Another is complex 0. And by the way, I suppose that the y-intercept is the point, look, comma, 0, comma, negative 240. Wow, it's too long, no? Let me make a zoom. There you go. At the point when the polynomial graph crosses the y-axis. Any question?
No, thank you.
No, my pleasure. My pleasure. I feel super good to you understand very well the thing. This is the magic. Try to make easy the complicated thing. Okay? Do you want one more example or no? Honestly, yes or no?
I'm good.
Okay, everyone is good. So we start new topic. We start new topic. New topic is a little bit more complicated. More complicated. New topic. Now, what is the name of this new topic? Let me see what is the name. Wow. Okay, the name of this new topic. Okay, new topic, new topic. Board here. Okay. Cancel, share screen. There you go. I suppose in this moment you watching the whiteboard. Yes or no? Yes or no? Whiteboard? It's clear now?
Yes, sir. Yes.
Excellent. Bueno.
Yes,
Let me
sir.
erase everything. Erase everything. Let me see. Erase everything. There you go. Okay. The topic, the new topic we're studying now is called. Let's call it. Okay, here in black color, rational. Rational functions. So we study polynomial. Now rational. What definition? What is the definition of the rational? Definition is a rational function. Let me call rational function. Is a division to polynomial. At the top we have one polynomial. In the bottom we have another polynomial. A p of x and q of x both are polynomial function exactly the same, similar to we studied in the previous section. But rational division to polynomial. Entonces, this brings me new complication. New complication. Right? Rational the division to polynomial. This brings me new complication. I want to explain using example. Let me start example one. Elementary kindergarten example. Suppose the function, let me call f of x, is 1 over x. Well, in this case, I can see in the top, we have only one number, que 1, que you can consider que es polynomial degree 0. And the bottom, we have 1x, que is a polynomial degree 1. Because the exponent is 1, no? Here is degree 0 because you consider que es 1, x to the 0 power. Y I know que x to the 0 power is 1 y 1 times 1 is 1, no? Regardless, what is the coefficient here? Suppose the coefficient is 10, because the coefficient is 10, no? But the exponent is 1. Do you understand very well degree 0 and degree 1? Yes or no?
Yes.
sir.
Okay.
Yes, sir.
Okay, very well. Degree, no, coño. All right, let me see. Eraser. What happened with the eraser? Well, that part is gone. And that part now is gone. I want to erase the rest. Let me see, erase this one. Okay, erase. This erase. Okay. This is the original rational function. Everyone understand this? I suppose I complicated more. This is more. This is elementary example, kindergarten example. This is the function. This is the original. Original. Okay. And now the factory form. Factory form. Very important because always the first job that we are doing to analyze the rational function is factorization. No? In this case, the factorization is one we can do nothing because one is one and x is x. And all the more interesting example, we are doing the factorization of the polynomial on the top is the factorization of the polynomial at the bottom. But in this case, no, it's impossible. Okay, now domain. Because the polynomial I know very well that the domain is all real number from negative infinity to positive infinity. But in the rational, no. Why no? The reason is no real number is because maybe the zero of the polynomial in the bottom, q of x, must be non-zero because division by zero is impossible. Division by zero is undefined. In our specific example, number one, is elementary, trivial, is x non-zero. Non-zero. And the domain is, well, express it in that way, x such that x non-zero. Because I know it's zero to be undefined, no? Because 1 over 0, what's the answer? 1 over 0, guys. When you divide by 0 is, what's the answer?
Zero.
What's the answer?
Zero. Zero.
No. I agree with you. You divide 0 divided by any number is 0. But if you divide any number divided by 0 is undefined. Okay? Undefined is the word que the mathematicians create to say no solution. We cannot find a number que divided by 0. It's impossible. So you put in a calculator. Calculator. You type it. 2 division 0. You see in the display. Error. Because it's impossible to divide by 0. Okay? No. You need to avoid division by 0. Everyone understand the elementary example number 1 or no? Confusing? Let me clarify example 2. Maybe it's more clear. Suppose a g function is equal to original. This is 5x squared. And the bottom we have x squared minus 5x plus 6. This is the original expression, polynomial degree 2 in the top, degree 2, and the bottom degree also 2. Okay, perfect. Now g of x, image, okay, take a picture. Oh, I forgot to record the video. Let me see if I record. Carajo, I forgot. No, I don't. Thank you. I would like que one student, I don't know, remind me or see at least one student or teacher press the record, we record. But I suppose I forgot sometime, no? But no, okay. Thank you. I appreciate so much your help. Okay, now the factor form, one of the factor form is easy because in the top we have this exactly the same, doesn't do anything, but in this case, no. In this case, I can break it down like that. X, and the combination is 3 and 2. 3 and 2 minus both. This is the factor form. So you are doing the factorization of the polynomial in the bottom, and you are doing the... Go ahead. Go ahead. Somebody have a question? The question, you activate the microphone, or you using the chat. It's the same. You type, But let me finish, because the thing we are doing now is too easy, no? I suppose. What is the factor form? The factor form is you take both polynomials, top and bottom, and we are doing factorization. And the top, we have monomial, stay the same, But in this case, we have trinomial, and the factorization is 2 binomial, like that. I suppose you remember the technique of factorization. The domain. Domain is a real number, no. Domain is when the denominator is not 0. In this case, is x minus 3 equal to 0, no 0, and x minus 2, no 0. Where come from this, you take this factor and no 0 both. Entonces es x, no negative 3, and x is no negative 3, no, sorry, positive 3. Then move to the right hand side. And where is the domain? The domain is all real number such that x is no 3 and no or, because at least one fail, it's not good. 3 or x is not 2. You try to evaluate, for example, you try to evaluate g and 3 and g and 2. I'm plugging in 2 here, 2 here, 2 here. In every case, the answer is undefined because we are doing division by 0. This is completely illegal value in this function. Therefore, the domain, by definition, domain is all real number except the number get to be undefined when you plug it into the original function. In this case, 3 and 2 is undefined. Now, it's clear or no? This is called algebra. This is called algebra.
Yes, it's good.
Yeah, it's good. It's called algebra. Stupid called algebra. Okay, no problem. No. Wait a second. No. Well, okay. Forget about this line. Okay, let's go to the example 3. More clear, I suppose. I don't know. It's clear or no. Suppose I call h of x. It's the name of the function. And the top we have binomial. Okay. And the bar we have binomial. But in this case, the degree of the polynomial in the top is 1. And the degree of the polynomial in the bottom is 2. Remember, the degree is the higher exponent. Exponent 1 here invisible, and 2 no is visible, is 2. Okay. However, when you try to do the factory form, well, the top stays the same because this is just a prime expression. We cannot do the factorization, but in this case, no. In this case, we can do factorization, but in complex field. But in real field, no. In the algebra, we studied before, always we are doing the factorization in the real field. The first time you see complex field is here in pre-calculus. But no. We are doing exactly the same of the algebra, like that, because we are doing the factorization in the factory form. The factorization in the top and the bottom is in the real field. Therefore, what do you think about domain of this one?
So I have a question.
Please.
Okay, in the denominator, isn't that 2 squares though? The x2 and the 4. So wouldn't that be x plus 2, x minus 2?
Si es minus, yes. Si es minus, yes, miss. Si es minus, es a famous.
Oh, if that was my, okay. All right.
Pero si es plus, remember, si es plus, the factorization is only possible in the complex field like that, 2i,
Okay.
plus or minus. Okay, super.
Thank
Good
you.
question. Entonces my question was, what do you think about domain of the our function? What do you think about domain? Erase, no canvas, no clear canvas, just clear. When I select, well, okay, don't worry. Delete, select this, delete, delete, delete. I need to delete one by one. I don't know why. Okay, no worry. I did that. Almost, I did that. Okay. So you thinking about domain or no? What is the domain of this rational function? What is the domain of this rational function? No idea. Eh? What is the value que guarantee que this is zero? This this polynomial to be zero. It's only the imaginary, right? Entonces, what is the domain? The domain is
-3.
negative 3. No. To find the domain, call it algebra. You take the expression in the bottom and enforce it to be zero. I don't care the expression in the top. No important. Because the reason is that I need to avoid division by zero. Division by zero is illegal. When it's zero divided by any number, no problema. But when there's any number divided by zero, it's problema. Therefore, this is zero in the top and the bottom, sorry, bottom. Okay? Entonces, the domain is a real number. How do you know que it's a real number? Because in the college algebra we study, I want to refresh your memory one more time. Listen to me, que this is important. In any function que you want to investigate the domain, the supposition is, you suppose that the domain is all real numbers, except restrictions. What is the restriction? The restriction is the value of the x in which the bottom is equal to zero to avoid division by zero. But in this case, we have no real number to satisfy this condition because the solution for this is imaginary, plus or minus 2i. You know that. And plus or minus 2i is completely out the real field. Therefore, the domain is a real number because our restriction living in another planet, not in the Earth planet. Do you understand this or no? Do you understand this or no?
Yes, sir.
Eso. One more example to clarify the idea for the domain, factory form. Suppose P of x. Suppose que es x squared minus 11x plus 30 divided by x squared minus 9x plus 18. This is the original expression. Degree 2 here. Degree 2 here. Same degree. Good. I like that. After you see the consequence of this. But no. Let's go to the factory form. The factory form is factorization. Trinomial. Two binomial. X. And the first one, the combination is 6 and 5. Because 6 times 5 is 30. And somehow 6 plus 5 is 11. Negative both. Do you follow me? Everyone is agree or disagree? Factorization of this.
Agree.
Agree. 18. 18 is 6 and 3. Because 6 times 3 is 18. And somehow 6 plus 3 is 9. Negative both again. And you can see, wow, look at that. This factor is cancelled. Do you understand get cancelled, right? Because x minus 6 divided by x minus 6 is 1. So any expression divided by itself is 1, no? And 1 is invisible. So we can eliminate that, and the answer is x minus 5 divided by x minus 3. Okay, this is the factor form, and this is the original. And we discovered that the factor x minus 6 we can eliminate in the expression. But be careful. I want to explain and detail this. Domain. What is the domain of the original expression? Remember, domain is always all real number except restriction. Restriction is the value in which the denominator is 0, okay, 6 and 3. The x minus 3, no 0. Therefore, this is x equals 6. And x minus 3, no 0. Therefore, x is 3. The domain then is domain is all real number x such that x no 6, this is no equal, or not. But I want to explain one important thing. I want to use it right now. No, from now. Okay, the behavior of 6 and the behavior of 3 is different. Both create the same problem, undefined, when you plug it in here. The P and 6 is undefined. And P and 3 is also undefined. But it's undefined for different reasons. Because you plug it in here, the only undefined is 3. So in 3, so at x equal 3, yes, it's undefined. It's totally out of the domain. But in this case, we have a vertical asymptote. Okay, we study in detail now vertical asymptote. Vertical asymptote, guy, we can represent something like that. This is the suppose this is the x-axis, and the rational approach it, but will never touch it. This is the vertical asymptote. That is the reason it's undefined. However, at x equals 6, no vertical asymptote. No. How do you know that? Because this factor is canceled, it's gone. So that you analyze in the new factor form, we have another thing is called a hole. A hole. What is a hole? It's also undefined, but it's different. When you are doing the graph of the function, maybe in 6. Okay, I agree. Okay, for example, here in 3, we have vertical asymptote. I don't know if it's like that or no, but in 6, we have no. In 6, we have a hole. And hole, you represent like that. Maybe. I am not sure the graph. I am doing the graph using this one. But this is the idea. Hole, how do you know hole or vertical asymptote? Easy. Because the factor gets canceled. It's a hole. Always. And the factor can stay in the bottom represent the vertical asymptote. Okay, super. This is theoretical. Blah, 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 blah. Let's go directly to example. Any question that you have about theoretical part? Factor 4, degree, domain. Okay, what is the formula for finding the domain? What is the formula? The formula is, suppose you have a rational function P divided by Q. The formula is you take P of the original and enforce it non-zero. Okay, and the solution for this inequality give me domain. Okay, let's go directly to study in detail now, details, vertical asymptote. This is completely new. The polynomial function have no vertical asymptote. No, what is that? I never seen before this. Okay, this is a value. Suppose that we have at x equals c. C represents value. But when you evaluate when the x approaches to c, approach, no necessarily touch. The function approaches to positive or negative infinity. Let me see. For possibility, we have to understand vertical acid. And normally, the vertical acid is represented by dotted line vertical line. Okay? And this value is x equals c. X equals c. X equals c. Hypothetical. I promise in the example you see very well, we're doing several examples. One possibility is, let me using another color, maybe blue, I like blue. Okay, the function look like that. Another possibility is that the function look like that. Another possibility is that the function look like that. Or another possibility is that the function look like that. How do you know that? Easy. Number one, you take the polynomial in the bottom, you enforce it to be 0, and after the simplification, we have no whole anymore. You take the solutions of this equation, no? Q of x equals, and you evaluate a little bit. Suppose, hypothetical. Suppose this value is 4. You evaluate a little bit before and after the 4. Suppose you evaluate here in the function in 3, and suppose you evaluate in 5. See, when you evaluate in 3, the answer is positive number. And when you evaluate in 5, the answer is negative number. The behavior is like that. And likewise here, you evaluate before and after, see if positive both. It's like that. See, this is negative, and this is positive. It's like that. And see, both are negative. It's like that. Super, super, super easy. Let's go directly to my first elementary example of the vertical acid. Everyone follow me, guys? Vertical acid. Wow. What happened? What's going on? Vertical acid. Did you see before this or no? Or is the first time you study with me this? Huh?
First time I've ever seen this.
Okay. Super. Let's analyze one elementary example. Suppose example 1. Suppose in the test I give you that function. I promise again the test I put more complicated. This is the first example. This is very, very easy. Entonces my goal in this example is analyze the vertical acid. Okay, nice. You take the polynomial in the bottom, you take this polynomial. I don't care the top part, no. And you solving this equation. It's obvious that the solution is x equal to. In 3, we have the vertical acid. But, well, I don't know because we have 4 kinds of graphic. I don't know if it's this or this or this or this. I evaluate, for example, suppose here, this is the graph, it's a 3. And you evaluate maybe in 2 and 4. So you evaluate the function n2. Here plugging in is 2 over 2 minus 3. 2 over -1 and -2. Therefore, that point is the point 2, comma, -2. That's negative. Suppose that this is 1, this is 0, this is the y-axis. This is the x-axis. I discover that is positive 2, negative 2 here. At this point, I plot that point, belong to the graph. And 4, Let me see what happened with the 4. 4 is 2 over 4 minus 3. 2 over 4 minus 3 is 1. It's 2 positive. Entonces the point is the point. 4 comma 2 positive. This is 4 comma 2. 1, 2. Here, positive 2. I suppose roughly sketch of my curve look like that. This is completely like that. This is asymptotically to this, right? But I know that is in the left is negative and the right is positive. So it's like in this case. This look like similar to this. Suppose I don't know anything. I have no idea. I am totally lost. I go to Desmos. Let me go to Desmos. Okay, Desmos now. Okay. Okay, there you go. Okay. Okay, this is Desmos, no? Okay, however, I want to, when I close this, save, just in case. I try to find another folder que I call rational function new. Que I start to create right now, before the class, a little bit. But I create only one example because I want to illustrate very well the process. Look, the example number 1, que es exactly the example que went like here. Look, I put f of x equal to over 2 minus x, 2x minus 3, sorry. And you evaluate in 4, the answer is 2. And you evaluate in 2, the answer is negative 2. Look at that, look at that. So I plot that. And I plot the point, is 4 comma negative here, using the function notation. Look, I typing 2 comma f evaluating 2 comma 4 comma evaluating 4. Automatically you create this point. Okay, and the vertical line is all is just x equal 3. So I change the style. Look, because the vertical line always by convention we use in black color dotted line. Black color dotted line. And you activate this. Bang. This is my vertical axis. Any question? Don't worry. Next example we are doing from scratch. Okay, we have no any clue, and we start at the beginning. Do you understand the idea of the how we can determine the vertical asymptote, and also how you do the sketch of the show?
I understand the point, finding the point on the graph in solving the equation, but I don't understand how the curve of the graph, why it curves that way. That's the part I don't get.
The curve, do you see I try to do in blue color? Yes or no?
Yeah, I saw it in blue, but I just don't understand because there was only one point, so that's why I didn't understand.
Okay, miss. We can plot several points if you want. Okay, you can plot several points, but in Desmos, you put the equation, automatically you can see the curve. Look, you put the equation, this equation. Mira, look, let me deactivate this, and deactivate. You put just equation, and automatically Desmos plot any point. But the problem is the interpretation of this. You can see in x equal 3, we have the vertical line, and the behavior is using 2 points, this and this. And you have more points. You can, why no? I suppose, comma, parentheses. You are watching the Desmos now? Please. Do you see the board or Desmos? Sorry. Miss. Hey, what's going on? Desmos, good. Suppose I plot 5, comma, I don't know exactly, f evaluating 5. boom, I plot this point. And so on, 6, 7, 10, oh, -2, 0, suppose 0, another point, comma, suppose open another parenthesis, 0, comma, F, evaluate 0. Boom, bada boom, this is the value. Maybe it's a fraction, it's logical. Okay, do you understand or no? Do you understand or no? Yes. ¿Es Vanessa Ballester? Okay. Let's go to the board now. Oh, let me see. Let me try. Board now. Okay, board now. Okay. Do you see the board? Okay. Do you see or no?
Yes,
Okay.
sir.
Yes, sir.
Yes,
Example 2 now. In the example 2, we have function. Let me use in black color. I like that color. G of x is equal x minus 3 divided by x squared minus 5x plus 6. Okay, this is the original rational expression, polynomial in the top, polynomial in the bottom, degree 1 in the top, degree 2 in the bottom. Entonces, immediately, step one in the analysis of the rational expression. Do the factorization. So express it in factory form. This is the I lost internet connection, sorry. Okay, Joyce. This situation happened, and normal. Okay, now I do the factorization. The trinomial in the bottom is negative. Okay, yeah, I realize. I realize that these 3 is cancelled. Chung chung. And we have 1 over x minus. What happened in the factor gets cancelled? What happened at x equal 3? So when I explained before, when the one factor is cancelled, what means that? What means that? No idea? You don't remember?
No, I'm not. Oh, you cancel out?
I explained today, coño. It's a whole. This is a whole. So when you are doing the factorization and one factor is cancelled, it's because the function, the original function, contains one whole and this factor gets cancelled. And what happened at x equal 2? Que es the factor que stay in the denominator in the factory form. What means that? What means this guy? Huh? It's a vertical positive. All right, pay attention and let me try to summarize. This is my original problem. Always is the same. The step number 1 is do the factorization. Polynomial in the top, polynomial in the bottom. I did that. What I realized that one factor is cancelled. When the one factor is cancelled, that means that at this value, we have a whole. And the factor that stay in the bottom is the vertical aspect. It's okay. This is the theoretical part. You need to memorize this. Or memorize or understand this. Okay? Now, let me try to do my elementary roughly sketch without decimals. Suppose my roughly sketch of the graph. At 2, here. 1, 2. We have a vertical axis. This is 3, and this is 4, and this is 5, and this is 1, and this is 0. Entonces I evaluate, suppose I don't know si es like that, or like that, or like that, or like that. It's another possibility. 4 possibilities. So you evaluate a little bit before arbitrary value. Suppose que you evaluate in 1. Suppose G function, evaluate in 1. Entonces you plug it in, pero plug it in the original function. Look, plug it in the original function. 1 minus 3 here. 1 minus 3. 1 squared minus 5 times 1 plus 3. In this case, we have minus 2. In this case, we have 1 minus 5 plus 6 is 1. A ver, 6 minus 5 is 1. Pero es positive 1, ¿no? Let me see, what's the 1? Es negativo. Es 2, ¿no? A ver, let me see. Es 2, ¿no? Es 1 plus 1, es 2. 6 minus 5 es 1, ¿no? Y 1 plus 1 es 2. Entonces es negativo. Ok, es negativo. Entonces en 2, que es here, es negativo. Y en 3 no, because in 3 I know that we have a whole. And 4, let's plug it in 4. And 4 is 4 minus 3, substitution aquí, replace x for 4. 4 squared minus 5 times 4 plus 6. This is 1 over something. This is 16 minus 20 plus 6. The G value in 4 is 1 over something. This is 2, because 16 minus 20 is negative 4, and negative 4 plus 6 is 1 half. So 4 is 1 half, but 1 half positive. It's a 1 half, I suppose que here, this point is the point 4 comma 1 half, 4 comma 1 half, and this point was 2 comma negative 1. Entonces I have, the intention is in here we have approximately, the graph is like that. I don't know exactly, but I investigate. It looks like that. But the most important now is the whole. The whole is in 3. Therefore, here in 3, we have the whole. The whole we indicate like that. So you erase this. And you indicate here a whole. A whole is on the file. This example have 2 new complications. We have here a vertical asymptote at x equal 2, and we have a whole at x equal 3. ¿Es clear or es confusing? Bueno, the time is over, no?
Yes, sir.
We continue. We continue next time doing the rational. Because rational is a little bit more complicated than polynomial, no? Because rational contain asymptote, and we study only one asymptote, que es vertical, but we have horizontal, oblique asymptote. Entonces more complicated. You never see before this in your life? Rational function. Okay, it's the first time with me. Okay, no problema. Okay, guys. Entonces, this video I upload in Blackboard. Okay? Thank you for your attention.
Thank you. Have a good afternoon.
Bye-bye.
Thank you, Professor. Have a good
Okay.
one.
Bye, Professor. Thank you.
No problema. My pleasure, always. Any question in the homework, let me know. Email me.